Hello, this video is for Stat 210 Handout 11 Part B and will cover pages 10 through 18. Part B is going to use the vitamin intake data set, and that is available in our Google folder for Handout 11. What is covered in Part B is actually going to be using information that we learned from handout number 10 and also information that we learned from handout number 11 Part A. The example that we're going to consider here is the vitamin data set that was done here at Winona State University. What we learned in handout 10 was, or what we investigated in handout 10, was whether or not the caloric intake for WSU students was on target. We computed the actual caloric intake and subtracted it from the daily recommended intake. We used that difference in our analysis. Here's a snippet of output from handout number 10, Part B. We learned that the confidence interval was completely negative. The confidence interval went from minus 461 up to minus 231. That meant that WSU students were taking in about 230 to 460 less calories than they should have been. Here's a snippet of the summary output from handout number 10, Part B. What we're going to do next here is look at whether or not the amount that they were under eating here. So here we learned that WSU students were under eating, at least on average. What we're going to do here in handout 11 Part B is look at whether or not that underconsumption or under eating is different between males and females. So we're going to again create that calorie difference column, but I want to now compare those calorie difference values for the males against the calorie difference values from the females. So the research question being considered here is the following. Is the average amount of undereating for the males different than the average amount of undereating for the females? So can I say that I have differences due to gender here in the amount of calories that WSU students are undereating? So here we have a stacked or side-by-side dot chart here. We have the females would be on the left here with the red dots, and males are going to be on the right with the blue dots. 0 indicates that they're on target. We can see that both of these averages are below 0. Their exact values can be computed in JUMP by selecting means and standard deviations. We can see females are undereating by about 400 calories, and males are undereating by about 150 calories. One thing that we notice with this data is that the standard deviation is fairly wide or fairly large. In other words, the amount of undereating or even overeating here tends to vary a lot from student to student. The other thing is that the number of observations here are not the same. We have 57 males and 57 females and 14 males in this study. There is a common misconception that the two groups must have the same number of observations in order to make fair comparisons in the means, and that is not true. You do not need to have the same number of observations in each group. We're using an average here, and an average takes into consideration the number of observations. So that is not a necessary condition. What we are really interested in is that gap between the males and females. So that's what handout 11 is about, is trying to establish whether or not that gap that I see in my means is going to be consistent over repeated sampling. To estimate that gap, all I need to do is to subtract the female mean from the male mean here. So I'm going to take the two averages that I had, which were 159.6, that was the average for males, subtract that from the average of males, which was minus 391. When I do that, I get a difference of 232. So that's just how big that gap is. 232. We would call that the variation between the groups here. When we look at the variation within the groups, I need to compute the standard error for the difference, and that's the equation for that quantity. Again, it uses the standard deviations and the sample sizes from each group. If I were to look at this difference, which here is 232.3, if I were to look at or observe that difference over repeated sampling, then I would end up with this distribution right here. The mean of this distribution is 232, and the variation or standard deviation is given by my standard error for the difference, which in this case is 182.9. That standard deviation is quite large relative to what my mean is. And again, that is occurring because I got quite a bit of standard deviation in the individual measurements as well. So the standard error of the difference certainly uses the standard deviation in each of these groups. And if these quantities are large, which again is just the variation within each group, if those quantities are large, then my standard error for difference is going to be pretty large. We can see that these dots do encompass a no difference situation. So that'll give us a little bit of a hint of what's going to be ahead. We're going to find out that the p-value is not less than 0.05 in this example, because it's quite likely that I will get a no difference over repeated sampling. So the hypothesis test, just the research question here, is the average amount of undereating for males different than the average amount of undereating for females? This is going to be another two-sided test. We actually look at the difference between the two means, so that's usually how we write that on the right-hand side. I again am just going to select t-test from my drop-down menu inside of JUMP. Here's my difference of 232. That's just the difference between the two averages. The standard error difference, that's given by that equation up above. I got the lower and upper confidence intervals. I got my t-ratio value, and I need my probability value for my p-value here. If we write out what the test statistic is, it is going to be the difference between the two means, which is 232.29, and dividing by that standard deviation in that distribution. When we do that, we get a t-ratio or a t-value of 1.27. That t-ratio is not very large. That is just telling me that the variation across the groups is 1.27 times larger than the variation within the groups. We need this quantity to be about 2, or above 2, or below -2, in order to say that I have a significant difference between the two groups. Let's go ahead and grab the p-value here. So the p-value, I'm going to use the 0.2224 value here. Again, I have a two-sided test. I have the not equal in the HA here. So I want to be using that for my p-value. I compare that against 0.05. That is not less than 0.05 here. So the data does not provide enough evidence for the research question. In other words, we fail to reject the H0. Our conclusion then, we are 95% certain that there is not enough evidence to say that the average amount of undereating for males is different than the average amount of undereating for females. So we don't have any differences between the males and females in the amount they're undereating. On the bottom of page 14 is the confidence interval, the 95% confidence interval. And again, what we do with the 95% confidence interval is just capture the middle 95% of those values from that sampling distribution for the difference between the two means. The lower end point here is calculated to be minus 155.7, and the upper end point is calculated to be 620.7, or that should be 620.25. This interval captures 0 here, so we can see that there is indeed no difference between these two groups. The interpretation then, statistical difference does not exist. So we learned that from the p-value and also from the 95% confidence interval. So this 95% confidence interval catches 0 here. It goes from minus 155 up to 620. So that's going to capture 0. So there's not going to be a difference between these two averages. We can see that a majority of the interval, so much of the interval, is positive. So what does that mean? Again, I took the differences, and the differences were computed as the average for males minus the average for females. So males is coming first here. So that means that the average amount that males are undereating is reduced compared to the average amount that the females are undereating. So males are not undereating as much as females. Again, I know that because this confidence interval here, a lot of it is capturing or is greater than 0. So that's telling me that the amount that the males are undereating is less than females. Checking the conditions of the test. So the two groups are most likely independent because each person has their own eating habits. One thing that we should notice up above, should have said this earlier, but let's go back up and look at those. It looks like the variability here tends to be different from the females and the males. We do have a couple of outliers or extreme values here for males. Okay, but the variability seems to be stretched out a little bit more for females than males. So we can actually do a formal test for comparing the two variances. So that is done here by just selecting unequal variances from my red drop-down menu. The p-values that are given, there's actually 5 here, 1, 2, 3, 4, 5 different p-values that are given. These are all for testing whether or not the variances are the same. It turns out that this test is kind of sensitive to different situations in the data. So what JUMP has done is provided just 5 different versions of that test. For this particular example, it doesn't matter which version of the test we use, whether it's O'Brien's or Brown-Forsyth's or the F2-sided. They all seem to indicate that I have unequal variances. Now, what we've done in Handout 11 is always use just the t-test here. The t-test does not actually need assumption number 2. Okay, so the t-test version done by JUMP does not require that the variances be the same. We talked about that in Part A of this handout. There is another version of the t-test called the pooled t-test. Now for this particular example, you're not going to want to use the pooled t-test because that assumes that the variability is the same. And what I learned from my unequal variance tests over here is that's not the case. The moral of the story here is if you use the t-test version in JUMP, you're always going to be safer because assumption number 2 does not have to be met or considered. Assumption number 3, though, is the normality in the observations. And you can see for the males, they tend to be a little bit more normal shaped than the females. Excuse me, I had that backwards. The females tend to be more normal shaped than for males over here on the left. One issue here is that I only have, 14 or 15 observations here for the males. So it's really hard to make a histogram look nice and bell curved with that few of observations. Okay, some additional things here. What happens if we were to remove those 2 extreme values for the males? So if I remove these 2 here, what that's going to do is let this average bounce up a little bit or become free of being drugged down. That goes from about a minus 150 up to a positive 18. So those 2 observations right there are dragging that average down for those males. If I take those 2 observations out, which I've done here on the right, then I'm going to get a bigger gap between them, and it's going to be easier for this gap to be more significant. And in fact, it is significant here. So the two-tailed p-value when those 2 observations were moved is actually less than 0.05 now. So I can say I have differences between the males and females. The 95% confidence interval does not capture 0 anymore. this interval is completely negative. Excuse me, completely positive. So that's saying that males tend to undereat less than females. Now you can't just haphazardly remove observations though. It would be bad just to remove these because you don't want those in there and you like the conclusion that you get without those in there. If these are legitimate data points that should be included in this study, then they should remain in your analysis. So this was just showing you what would happen if those two were removed. Finally, let's quickly investigate the effect of BMI, in addition to what I've already been considering. So here on the left, I was looking at the differences in the amount of undereating between males and females. And here I put those two observations back in, or left them in here. So that's what that two sample t-test is going to do. Well, what if I also wanted to consider BMI, or body mass index, of each person? Then I'm going to need to use a scatter plot. So here I have BMI across the x-axis. I have the calorie difference on the y-axis. And then I've marked my points by either males or females here. And then I just kind of put these trend curves or trend lines inside of the scatter plot. You will learn a lot more about this type of thing if you were to take Stat 310. So what do I observe here when I bring BMI into the discussion? Well, I learned that when the BMI is low, okay, so if I'm in kind of, see if I can get this here. If I'm in kind of this region down here, so about 18 to 20 or so, I can see that the BMI, that the males and females tend to be pretty similar here. Their trends are kind of in the same spot. Also, if I were to go up high, so 24 and above, I see that I have similar trends between males and females, at least according to these curves that I put in this scatter plot. However, in this middle region here, from 20 to 24, I can see that I have a pretty big difference here between the males and females. And in particular, females tend to stay down below their target. So females tend to be undereating in here, whereas males tend to be close to target or even actually overeating in this region. So the effect of BMI, or is there an effect of BMI? There is. Okay? When we're kind of in the healthy region from 20 up to 24, there's a difference between the males and females. That difference doesn't exist when the BMI values are real low or when the BMI values are high. Also, a third bullet down here, there is less effect of BMI for females. We can see that the effect of BMI is fairly flat, okay, for females. That trend line or curve there that I put in that scatter plot, which is for the females only, is fairly flat. In fact, it dips down a little bit, so the amount of undereating is worse for people with high BMI than it is for people with lower BMI, at least for females. So if this line was perfectly flat, then we would say BMI has no impact at all. Okay, that does it then for this handout, which is handout number 11 Part B, pages 10 through 18. Thank you.